All right, good morning. So LK, I don't think we've actually talked in public before about how Tipping Point and ACO spun out of Flight Opportunities. So I'm actually gonna go off script for a second here. I worked for LK for a number of years, and the problem he was describing is we were trying to facilitate this new suborbital industry where NASA was going to be one customer of many, and there were going to be commercial customers and other customers that were going to buy these flight services alongside NASA. And we were trying to help establish this market. And so we were buying flights. But as we were buying flights, we were finding that just wasn't enough. The industry needed more than for us just to be a customer early on. And so we began to look at, well, how can we support these companies with their testing and their development of their technologies? That was for the suborbital industry. Now, is there potentially a parallel to some of what we're trying to do today? I don't know. I'll leave that for you all to decide. All right, so I am the program executive for the Flight Opportunities and Small Spacecraft Technology programs within STMD. There we go. All right, so within that portfolio, we seek to increase the pace of space exploration, discovery, and the expansion of space commerce through rapid identification, development and testing of capabilities that exploit agile spacecraft and responsive launch capabilities, including suborbital, from industry providers. We engage in risk-tolerant technology development and demonstration, and seek to provide rapid access to space test conditions, both suborbital and orbital, to de-risk technology and support American global competitiveness in space. So within STMD, we have a fairly wide range on the TRL spectrum. Additionally, we also have a sliver of that strategic framework that Walt mentioned. This is the part of that framework that pertains to trying to leverage agile spacecraft and responsive launch capabilities to expand space capabilities for the U.S. So we want to have technologies that can rapidly make, support technologies to rapidly make that leap from laboratory to flight, whether that is a suborbital or orbital test, and then beyond. We think smaller, lower cost, faster commercial systems have the potential to create unprecedented deep space infrastructure around the moon, for example. Also in other areas, obviously, we think low cost, on-demand missions beyond Earth are of interest. Using those smaller, lower cost platforms that can be developed and fielded more rapidly, and you can iterate through those cycles. With a lot more risk tolerance, and then increase that pace of innovation through those cycles. So, commercial vehicles, in our opinion, make these flight opportunities possible. So within the Flight Opportunities program and the Small Spacecraft Technology program, we have access to a number of commercial vehicles. Most of these are through Flight Opportunities. So we've got rocket-powered test vehicles, whether that is commercial sounding rocket type platforms, or we also have access to some of the larger systems like Virgin Galactic Spaceship Two and Blue Origin's New Shepard. High altitude balloons, we have commercial systems that can do station keeping and other capabilities that may be of interest for testing technologies, especially those pertaining to remote sensing or communications, where you can use that balloon as a surrogate for an orbital asset. Potentially particularly of interest to this community are the next two, which are the parabolic flights, where we can not only have periods of zero gravity on aircraft, but also periods of lunar gravity, which has applications obviously for things you want to make sure they were going to work on the lunar surface. And then our VTVL capability that we have currently through Astrobotic, formerly Maston, has been used to test a number of terrain relative navigation and hazard avoidance systems that have already been used on Mars and will hopefully be used on the moon here real soon. And then through partnership between Flight Opportunities and the Small Spacecraft Technology program, we're adding access to platforms on orbit that can host payloads, whether those are smaller spacecraft or orbiting maneuvering vehicles and other similar systems that are coming online that have the capability to go to a commercial company and effectively get, they'll say it as space as a service, where we can put a payload on the vehicle, much like we do with these suborbital vehicles. They handle integration and flight, and then we get the test data back for the commercial or academic or government payload that's on board. So here are kind of the funding mechanisms that we have currently within that portfolio. I don't quite have as many as Jen, but we have a few. But we use kind of the full spectrum. We have both challenges, the NASA Tech Leap Prize, which talk about a little bit more in a minute. That is a mechanism by which we use that prize and challenge authority Jen referenced to access a wider swath of potential folks who have solutions to problems that we're trying to solve. Tech Rise is our student challenge. So grades, middle school, high school students get a chance to build payloads and fly them, which is really kind of inspiring for the next generation, hopefully. Tech Flights is probably, I would call it, are somewhat of our workhorse external solicitation for flight opportunities. The latest one was supposed to be out now. It's not quite out, should be coming out shortly. If you're familiar with the STMD strategic framework, the main topics in there will be familiar to you. We've also added a partnership with SMD on this round, where we're working with Biological Sciences, Physical Sciences, Cirrus Initiative, where we've been looking to enable rapid technology development demonstration. They're looking to enable rapid science. And so they're looking for laboratory systems that could basically be flown on suborbital vehicles, ultimately maybe be used on commercial LEO destinations, Gateway, or even the lunar surface. So we talk about trying to get your technology from lab to orbit. They would like to bring your lab to orbit. Jen's already talked about SBIR and STTR. We partner with them as much as possible. We also have a University Smallsat Technology Partnership that was just released yesterday, so that's out on the street. Again, technologies there largely looking at how small spacecraft can support future missions. Obviously, LK just talked about our role in ACO and Tipping Point. Perhaps the other interesting things are these kind of unsolicited proposals and other mechanisms. So we have within both programs what we call missions of opportunity and flights of opportunity. Effectively, if you are already, U.S. government, or you have a pre-existing relationship with the U.S. government for a technology, whether that's a grant, cooperative agreement, contract, prior SBR award, and you believe that a suborbital test or an orbital, commercially hosted orbital test would be of value for your technology, we'd like to hear from you. We can use those mechanisms to augment your grant, to do a phase 3 or a phase 2E on your SBIR award, or talk with whoever owns your contract, and work on seeing if we can get that flight for you. Obviously, it's fairly, while it is unsolicited, it is fairly competitive in terms of desire for folks to do this. So no guarantees, but certainly trying to lower that barrier to getting your technology into a relevant test environment. All right, so I already mentioned that we've used these test beds to test a number of systems that are hopefully going to be used for landing on the lunar surface here, the Doppler navigation LiDAR being one of them. A previous example, we helped test the technology that helped Perseverance land on Mars, the TRN and Doppler NDL. Nope, wrong acronym again. The hazard avoidance system, which I'm blanking on the acronym right now. Apologies. Particular interest, we under the challenge, we have the nighttime precision landing challenge that we're hopefully going to be flying technologies this summer with Astrobotic. They're testing the technologies from 3 winning payload teams that have developed sensors that are intended to help land spacecraft in tricky conditions in permanently shadowed regions of the moon. They'll fly on that lander over a terrestrial lander testbed over a simulated lunar terrain feature with hazards, and will be done in the dark. So that, again, we're looking to use those challenge mechanisms to reach a wide array of potential solutions and then get those into flight. As we're looking to the next iteration of that challenge, we're looking for ideas, and this is probably the community that would be worthwhile, I think, reaching out to, asking the question, what capability challenge are you facing right now that, if addressed, could support more rapid and affordable access to the moon? So if you have ideas on how we could help you solve those problems, Greg and Liz, could you raise your hands? Talk to them or me, and we'll be very interested in seeing what we can do. So there's a number of other systems here that we're hopefully going to be flying. Well, we've already flown suborbital, hopefully going to be flying to the moon here soon. Planet Fact being one of them. Sparta, Greg, this is probably, if people have questions, you're more the person to talk to. But basically, sampling lunar surface. It's flown in parabolic flights, and what we are doing soon is we're going to be flying on a mission that we have with Blue Origin, where they are going to separate their New Shepard capsule and spin it up so that the whole capsule, or at least the payload sections of the capsule, get lunar gravity. And then we will be testing 12 technologies, this being one of them, and there's a few more coming up on this slide here. So, things that are designed to test the fundamental physics and chemical properties of lunar regolith. Interestingly, the Europa's gravity is about the same as the moon, so we're going to be testing some stuff for SMD with microfluidics for life detection. Lunar gravity seems to be potentially a sweet spot in a bad way for flame propagation. So doing some work there on crew safety, similar dust mitigation, and then some interesting mobility surface things that we're looking to see if we can help test those in the lunar gravity. So just kind of closing here with some of the small spacecraft stuff. So Jen mentioned Capstone. Capstone, if you're not aware, was kind of our first commercial mission here to the moon, entered into the near rectilinear halo orbit that's intended for Gateway, demonstrating that the stability of that. The prime on this advanced space is also testing out their cislunar autonomous positioning system. That's the CAPS part of Capstone, while in the NRHO using both one-way ranging using a chip-scale atomic clock, as well as cross-link ranging with the Lunar Reconnaissance Orbiter, trying to demonstrate lower use of assets like Deep Space Network. So as we do have a propagation of future lunar missions, those networks are not overtaxed. That was a phase 3 contract with Advanced Space. So they came in with an idea, and we were able to effectively directly fund that, and have had a very successful mission now at the moon, operating for over 23 orbits. Obviously, if you follow along, it was not without its challenges, but I'm really proud of what that team was able to accomplish. Lunar Flashlight also been having some challenges. Less likely, unfortunately, we're going to be able to overcome the propulsion system challenges we've had on board there, and actually get into a lunar orbit, or an orbit that passes by the lunar South Pole. However, we have learned a lot from that mission, and specifically lessons on the propulsion system and the additively manufactured tank that we will be incorporating in the future mission. So from that standpoint, very valuable in that we learned those lessons on a smaller, low-cost, risk-tolerant mission, rather than on another mission with a different risk profile. And then I'll kind of leave this slide talking about the University Small Sat Technology Partnership. So again, that was just released yesterday, and we've got a number of examples from that have gone from that kind of laboratory development into suborbital flight, and several of which, like the one you see there, I'll hopefully be supporting lunar activities. In that particular one, it's a UT Austin and JSC partnership for crater-based navigation. And we've also got a 5G array that is going to fly on a balloon from San Diego State and partnered with Goddard or Glenn that can use that phased array for steer a beam for communications. It could be used for something like a lunar communications network. I'll be around for this morning. Greg and Liz will be around all day, and happy to take any questions, or if you guys have things that you think we can help you fly, please come talk to us.